Hello, and welcome to the SAP HANA Academy. My name is Tom, and in this series of videos, we'll be looking at SAP S/4HANA. In this series, we'll be looking at extending SAP S/4HANA with external data. In the seventh part of this series, we'll show you how to create a CDS view off of an external view. An important note about this series is that we will be showing certain features in the SAP HANA database which you may require specific licenses, even if we're using SAP S/4HANA. We've covered this in other videos previously, but if you do not have the features listed below, please contact your account executive or partner manager to see if you are licensed to use them. In part 6 of this series, we tested our SAP HANA calculation view, added a role to the SHA user we created earlier, and then switched out the SAP HANA perspective in Eclipse to the ABAP development perspective. There we created an external view for our ABAP dictionary, and this external view consumed the SAP HANA calculation view. So thus far, we've gone from creating a remote data source, either from Hadoop or a file system, depending on the method you chose, to viewing our external data in an ABAP external view. Now that we've done those tasks, we can create a CDS view in our ABAP data dictionary that will in turn consume that external view. We will then be able to return the external data in our CDS virtual data model. In this video, we'll be creating a basic type CDS view against that external view. For those of you who have not yet seen how to build a virtual data model using CDS and SAP S/4HANA, then please go to the SAP HANA Academy, which can be found by doing a browser search on SAP HANA Academy, and it will direct you to our YouTube page. Once there, please scroll down to the S/4HANA section and open the Modeling with SAP S/4HANA CDS Creating a Sample Virtual Data Model playlist. For this particular video, you don't need to have completed these particular lessons, but they are helpful if you have not used CDS for ABAP before. In later lessons, you will need to have completed those lessons, as we'll use the virtual data model created in that video series. To start creating our CDS, go back into Eclipse. Then go to the Projects panel in the ABAP development perspective. Right-click on the $TPM package. Choose New, Other, ABAP Repository Object, and then type in DDL, and then select DDL CDS. For the name, do ZXSH_I_AIRPORTGEO, Airport Geo, where SH represents our username and the I represents an interface view. For the description, add Airport, Geo, and Service, Private View, comma, VDM interface view. Press Next. Next again. Ensure that Define View, the default template is selected, and then press Finish. If you have never built a CDS view before, you can see that you're automatically presented with some default syntax for your view. This portion of the view is the annotations section, which defines the view itself. In the brackets, we will later add on our field for the external view, and also some annotations which further define these fields. First, we can work on the view level annotations. We can delete the line regarding comparing filters, as we are not filtering this data and it is a singular entity that we are using for this view. This particular annotation is useful when comparing multiple filters, as the name suggests. For the authorizations annotation, we can delete $check, press Control Space for autocomplete, and then select $not_required. We are not setting up a corresponding security or control file or DCL file for this CDS view or DDL file. Plus, this data is actually dimensional data coming from Hadoop, and we are not concerned about securing it further other than using the technical user and password that we used earlier in the remote data source setup in SAP HANA. The end user text label, which provides developers some information on the view, can be changed to airport, geo, and service. And we'll be adding our own external airport GDS coordinates as the airport service URL. So please delete the private view VDM interface view. To match our naming convention, we should change the case of the view name in the define view line, and it should be ZXSH, all in uppercase, underscore I, underscore airport, and then capitalized geo, so that the first 5 letters of it are capital and the remainder are in camel case. For the ABAP SQL view name, we will use ZXSH underscore I airport geo. The SQL view name should be in all uppercase, and the underscore after the I in the original interface view name has been removed. As this view will be used to further define airport information that exists in another CDS view, we will add an annotation to indicate to analytics that this current view will be dimensional data. This particular line can be added below the end user text label. Start to type in ampersand analytics period, and then code completion should come up, and then select analytics.data category. Then press Control Space and choose the # dimension option. We will next add another annotation to indicate what level or type of view this is. As we are in essence creating the first level of CDS for this new data, we will need to annotate it as a basic view. Basic views are the first level of views and are typically used directly against tables. So below the analytics line, type in ampersand VDM period, and then double click on view type for the code completion. Then use the code suggestion, Control Space, and select # basic. For now we are done with the view level annotations, so we can start defining our data set. Double click on data source name and type in ZV and then hit Control Space. You should see the external view ZVSH underscore airprt serv that was made earlier. Double click on the view to add it to this view. Double click inside of the 2 brackets, and now we are able to add in the field from our external view, which again is accessible as part of the ABAP data dictionary. Press Control Space again, and then double click on Insert All Elements. And the 4 fields from our external view will be added. The next step is to add the field level annotations to those 4 fields. The first field, the 3-letter airport code, is the key field in the data set, so we will add the word key to the beginning of that line. The next 3 fields will add semantic annotations to further describe the fields, as these annotations are useful when consumed in analytics later on. Add in the new line above the second field, and type in ampersand semantics period. If you haven't done this before, then please scroll down through the list and you'll see all of the different semantic annotations that you can assign to a field. In our case, we need to further define the next 2 fields as geospatial type fields. So type in geo, and then Control Space, and then select geolocation.latitude for this first field. Repeat the same process for the next field by typing in semantics.geo, but this time choosing longitude. The last field is the airport web service, and we'll add another semantic type. So type in ampersand semantic again, period, and this time we'll be looking for the URL annotation. So URL. One could also add an alias to each field to make the field names more readable to the end user, but these names are okay to leave as they are now for this view. We only have one more thing to do for this basic view, and that is to define at the view level what our representative key field is. So add another line below the view type annotation and type in ampersand object, and then select object model representative key. Then from the first key line, copy airport code and then paste it in to the representative key. Again, this annotation is, as the name implies, for the field in the dataset that is most representative of that dataset. In our case, we only have one key field, so that decision is easy. We can now activate our view, If there are no issues, i.e. nothing comes up on the problem log below, then we can preview our CDS view. In the view, select ZX SH_I_ airport geo, right-click, and choose to open with Data Preview. If all went well, you should see the data is being returned. We've now gone from creating a remote data source in SAP HANA to adding this data into our ABAP data dictionary in a CDS view. In the next video, we'll show how to add this data to another CDS view via an association, which is like a join for CDS. And then we'll see our external data being returned with the data in our SAP S4HANA system.